The Trachtenberg system is a system of rapid, mental calculation. The system consists of a number of readily memorized operations that allow one to perform arithmetic computations very quickly. It was developed by the Russian Jewish engineer Jakow Trachtenberg in order to keep his mind occupied while being held in a Nazi concentration camp. The rest of this article presents some methods devised by Trachtenberg. These are for illustration only. To actually learn the method requires practice. Students begin learning the Trachtenberg system using multiplication algorithms. These initial algorithms are discussed first, followed by a more general method for multiplication. Even if you know well how to do arithmetic, the Trachtenberg method can be faster. It is also a method you may use to check work done by more traditional methods. Beginning to multiply using the Trachtenberg method. When performing any of these multiplication algorithms, the following steps should be applied. Write a 0 before the number to be multiplied. The answer must be found one digit at a time, starting at the least significant digit, the digit to the far right. Move left one digit at the time to work. The last calculation is on the leading 0 of the multiplicand. When working with the multiplicand, one digit at a time has your primary focus. The digit immediately to the digit's right is that digit's neighbor. In the Trachtenberg method, never use the digit immediately to the left as the neighbor. The rightmost digit does not have a neighbor as there is no digit to its right. Some algorithms ask for a value of a digit's neighbor. When the focus is on the last digit to the right, the value used for the neighbor is always 0. The halve operation has a particular meaning to the Trachtenberg system. If a digit is even, take half this value. If a digit is odd, mentally subtract 1 before taking half the value. Alternatively, half the odd digit may be taken discarding any decimal, fraction or remainder. For speed reasons, people following the Trachtenberg system are encouraged to make this halving process instantaneous. Instead of thinking half of 7 is 3.5, so 3, it's suggested that one thinks 7, 3. This speeds up calculation considerably. The Trachtenberg system also uses something called the tens complement. In the same way, the tables for subtracting digits from 10 or 9 are to be memorized. This requires subtracting digits from 9 except the last digit to the right of a number which is subtracted from 10. The suggestion is to be able to look at the digits 0 to 9 and immediately know the result if this digit was subtracted from 9 or subtracted from 10. Whenever the rule calls for adding half of the neighbor, always add 5 if the current digit is odd. There will be more discussion on the reasons and details of these methods below. Multiplying by 10 equals, it is easier to simply append a final 0 to multiply by 10, however it is important to understand also how to multiply by 10 using a Trachtenberg type of technique. This technique will be used when Trachtenberg multiplies by 11, 12, 8, and 9. We will use the multiplicand ab as an example. In the Trachtenberg method, place a leading 0 on the multiplicand. We will write the answer just below the multiplicand. Think of 0 ab and the answer below it in columns. You will do a procedure to a digit in the multiplicand, and this will give the digit in the answer directly below this digit in the multiplicand. The first column considered is that on the far right. In this case, this column has AB in the multiplicand. The process proceeds from right to left. 0 ab x 10 equals, ab O. Rule: for each digit in the multiplicand, take 0 times that digit and add the neighboring digit immediately to the right in the multiplicand. Carry as you normally would in addition problems to the next column to the left if the value exceeds 9x. If the answer is 10, write down the 0 and carry the 1 in the next column to the left. In the first column on the right, start with 0xb. There is no neighbor to the right of b, so consider the neighbor value to be 0. Plus 0 equals 0. Write down 0 underneath the b in the answer. In the second column from the right, use 0 times a. The neighbor to the right is b. Plus b equals b, so write b in this position, a in the second column in the answer. In the third column from the right, which is the leading 0 in the multiplicand, 0x the digit itself equals 0 times 0 equals 0. The neighbor to the right is a. O plus a equals a. Write A as the answer in this position. Notice that if done correctly the answer should be as expected. The multiplicand moved one place to the left and with a 0 in the ones position. This is likely how you were taught to multiply by 10 in early grades. 327 x 10 equals 3270. 4268 times 10 equals 42,680. Notice we have made a big deal in that it is 0 times the digit first. Why? Later the multiplier for each digit may not be 0, so we are making sure to be clear that for this case it is in fact 0. Now that we know how to multiply by 10 by the Trachtenberg method, what is the payoff? Taking 1 times the digit in the multiplicand and also following the multiplication by 10 rule i.e. adding the number to the right would result in multiplying by. This would be 11 times the multiplicand. Doubling each original digit then following the rule for multiplying by 10 would be equivalent to multiplying by. This would be 12 times the multiplicand. This is discussed in the next 2 sections. Would be possible to triple the original digit and then follow the 10 rule to multiply by 13, and quadruple the digit and then follow the 10 rule to multiply by 14. It brings up the possibility of 22 times the multiplicand as 2 times the digit itself plus 2 times the neighbor to the right. For these beginning multiplication algorithms, Trachtenberg limits his memorized math facts down to multiplying by 2. After the beginner algorithms, Trachtenberg will go more in depth regarding extending his method to a general method for multiplication. Look for that in the later section on general multiplication. Just realize with this algorithm that adding 1 times the neighboring digit to the right means adding 10 times your original multiplicand to your answer. Example: 03424 x 10 equals 34240. Plus 3 closing round bracket plus 4 closing round bracket plus 2, plus 4 closing round bracket plus 0 closing round bracket. Equals multiplying by 11 equals, rule, add the digit to its neighbor. Example: 03425 x 11 equals 37,675. Each of these digits comes from 1 times the digit in the multiplicand plus the neighbor a, the digit to the right. Read these from right to left. Equals 0 plus 3 closing round bracket. Why does this work? Because 11 equals 1 plus 10. Using the digit itself and the moving the digit to the right over 1 column to the left accomplishes, thus. 03425 plus 34,250 equals 37,675. Note: after learning the basic method for the algorithms from right to left, some students practice also from left to right. This entails backing up and correcting for carrying, so is mentally more difficult, but it is possible if the problems involve higher numbers requiring carrying in the addition. Equals multiplying by 12 equals, rule, double each digit and add the neighbor. If the answer is greater than a single digit, simply carry over the extra digit to the next operation. The remaining digit is 1 digit of the final result. Example: 0316 x 12 equals 3792. Determine neighbors in the multiplicand 0316. Digit 6 has no right neighbor, digit 1 has neighbor 6, digit 3 has neighbor 1, digit 0 has neighbor 3. Plus 0 equals 12 right there, plus 6 plus 1 equals 9. Where did that final 1 come from? This is the one you carried from 12 in the column immediately to the right. Plus 1 equals 7, plus 3 equals 3. Equals multiplying by 5 equals, rule, to multiply by 5, take half of the neighbor, then, if the current digit is odd, add 5. An odd number equals 5x. An odd number equals 5x equals plus equals 10x 1/2 x. An even number. An even number equals 5 times an even number equals 5x equals plus equals 10x 1/2 x. The even number. Notice that x, an even number, may equivalently be calculated as 10x. Handle the 1 portion of odd numbers when multiplying by 5 by adding 5 to the answer in that column. Handle the even portion of the number by waiting until your focus has moved 1 column to the left, then add half the neighbor to the right. This last bit may also be described as adding half the neighbor, discarding any decimal, fraction or remainder. This fraction is not being thrown away. This additional portion was handled one column to the right from your current focus when you added 5 if the number was odd. You do not wish to count this portion twice. Examples. 042a, 5 equals 210. Half of 2's neighbor, the trailing 0, is 0. Half of 4's neighbor is 1. Half of the leading 0's neighbor is 2. 043a, 5 equals 215. Half of 3's neighbor is 0. Remember also to add 5 because 3 is odd, half of 4's neighbor is 1. Remember to discard any fraction when you divide by 2 for this method. Half of the leading 0's neighbor is 2. 093a, 5 equals 465. Half of 3's neighbor is 0, plus 5 because 3 is odd, is 5. Half of 9's neighbor is 1, plus 5 because 9 is odd, is 6. Remember to discard any remainder when dividing by 2. Half of the leading 0's neighbor is 4. Remember to discard any remainder or fraction when dividing by 2. Equals multiplying by 6 equals 1 plus 5, 1 times the digit, and add in the multiplication by 5 rule. Rule: to multiply by 6, take the digit, add 5 if the digit is odd, then add half of the neighbor to each digit. Example. 0357a, 6 equals 2142. Working right to left, 7 plus 5 plus 0 since 7 has no neighbor to the right equals 12. Right 2, carry the 1. 5 plus 5 plus half of 7 plus 1 equals 14. Right 4, carry the 1. 3 plus 5 plus half of 5 plus 1 equals 11. Right 1, carry 1. 0 plus half of 3 plus 1 equals 2. Right 2. Note: remember when taking half of a number in the Trachtenberg method to discard any remainder or fraction. Equals multiplying by 7 equals 2 plus 5, double each digit and also add in the multiplication by 5 rule. Rule: to multiply by 7, double each digit. Add half of its neighbor. If the digit is odd, add 5. Example. 0523a, 7 equals 3661. Double the 3, add half the neighbor, 0 as there is no neighbor, and add 5 as 3 is odd. 11 so write 1 and carry 1. Plus opening round bracket 1 over 2x 0, plus 5 equals 11. Double the 2, add half of 3 discarding any fraction. 2 is even. Add in the 1 carried from the 11 total in the prior column. Plus 0, plus 1, equals 6. Double the 5, add half of 2, add 5 since the 5 is odd. 16 so record 6 and carry 1. Plus 5, equals 16. Double the 0, add half of 5 discarding any fraction. 0 is even. Add the carried 1 from the 16 total in the prior column. Plus equals 3. Equals multiplying by 9 equals, multiplying by 9 is equivalent to multiplying by. This method also relies on the fact that adding a number to a problem then subtracting that same number results in no net change to the problem. Let's multiply QRSTX9 where Q, R, S, and T are each digits in a 4-digit number. A leading 0 is placed in front of QRST giving us 0 QRST. Always remember to place a leading 0 in front of the multiplicand. 0 QRSTX9 equals plus. How will you work with -1x0 QRST? Try adding a multiple of 10 that is just larger than QRST a 1 followed by as many zeros as there are digits in your multiplicand excluding its leading 0. In this case this means we will use 10,000 as QRST is a 4-digit number. If you add in 10,000 this will change the problem unless you subtract this back off later. 10,000-1x0 QRST, plus 10x0 QRST, minus 10,000, 9x0 QRST. In the initial step, you can see why each digit in QRST is subtracted from 9 except the rightmost digit which is subtracted from 10. This process completes 10,000. This step is called finding the tens complement. This procedure is not unique to the Trachtenberg method. See method of complements in Wikipedia. Adding the digit to the right in the multiplicand 0 QRST is equivalent to multiplying by 10 and adding this to your answer. Finally, when working under the leading zero of the factor 0 QRST, do not try to create some sort of tens complement for this zero. Remember, this is just a placeholder and not part of your original multiplicand. Add the neighbor AQ of QRST minus 1. You must remember to use Q as a neighbor, otherwise you have completely multiplied QRST by 10. Subtracting 1 in this final step is the equivalent of subtracting 10,000. You added 10,000 to perform the problem. It must be removed or the problem will be incorrect. Your digits in your answer should be 0 QRST x 9 equals Q1, 9Q, plus R, 9R, plus S, 9S, plus T, 10T. Editor's note, read the underlines as separating the different digits. Rule, subtract the rightmost digit from 10. Subtract the remaining digits from 9. Add the neighbor. For the leading zero, subtract 1 from the neighbor. For rules 9, 8, 4, and 3 only the first digit is subtracted from 10. After that each digit is subtracted from 9 instead. Example, 02, 130, 9 equals 19,170, working from right to left, 10 is 0, plus 0 equals 10. Right 0, carry 1. 9 are 3, plus 0 plus 1 equals 7. Right 7. 9 are 1, plus 3 equals 11. Right 1, carry 1. 9 are 2, plus 1 equals 9. Right 9. 2 are 1 equals 1. Right 1. Equals multiplying by 8 equals, rule, subtract rightmost digit from 10. Subtract the remaining digits from 9. Double the result. Add the neighbor. For the leading zero, subtract 2 from the neighbor. To understand what is going on here, understand that 8 equals minus 2 plus 10. Again, let's use QRST as an example 4-digit number. 1x0 QRST, 1x0 QRST, plus 10x0 QRST, 8x0 QRST. How do you work with 0 QRST? You work with the tens complement. This means adding in a multiple of 10 with as many zeros as digits in your original multiplicand i.e. 4 for 0 QRST. Since you're working with minus 0 QRST twice, you must add this multiple of 10 twice. This is only to make the working easier. You must remove these later if your answer is to remain correct. This is equivalent to plus 10,000, 1x0 QRST, plus 10,000, 1x0 QRST, plus 10x0 QRST, minus 20,000, 8x0 QRST. This simplifies to 2x, plus 10x0 QRST, 20,000, 8x0 QRST. So you find the tens complement of a digit and double it. Add the neighbor to the right i.e. use the multiply by 10 procedure and add that. When working under the leading zero of the multiplicand, get the neighboring digit to the right in the multiplicand and subtract 2. This step subtracts the 20,000 you added to work the problem. Use this neighbor to the right minus 2 as your leftmost digit in your answer. Your digits in your answer should be 0 QRST x 8 equals Q2 2x plus R2x plus S2x plus T2x, 10T. Editor's note, read the underlines as separating the different digits. Example, 456 8 equals 3648, working from right to left, 10 are 6, 2 plus 0 equals 8. Right 8. 9 are 5, 2 plus 6 equals 14, right 4, carry 1. 9 are 4, 2 plus 5 plus 1 equals 16. Right 6, carry 1. 4 are 2 plus 1 equals 3. Right 3. Equals multiplying by 4 equals minus 1 plus 5. Minus 1 times a number means in the Trachtenberg method a tens complement is used. 5 times the number should suggest to you the multiply by 5's rule. minus 1x0 qrst, plus 5x0 qrst, 4x0 qrst. You're working this as 10,000-0 qrst, plus 5x0 qrst, 10,000, 4x0 qrst. The 10,000-0 qrst is the tens complement. Subtract each digit from 9 unless it is the digit to the far right. For the digit to the far right, subtract it from 10. The leading 0 and 0 qrst is not used to find the tens complement. In other words, this is the same tens complement procedure you have been using. Add to your answer i.e. to your tens complement, the multiplication by 5 procedure. Remember, you add 5 if the number is odd and 0 if even. Add half the number to the right, discarding any remainder or fraction. While working under the leading 0 of your factor, decrease your answer for half the neighbor by 1. You added 10,000 to make the work easier. You must subtract that back out at the end or you will have changed the problem and end up with a wrong answer. Your digits in your answer should be 0 qrstx4 equals 9q, plus 5 if q is odd, plus 5 if r is odd, plus 5 if s is odd, plus 5 if t is odd. Remember a set of equations for the digits in this example. When a number divided by 2 is written, discard any remainder or fraction. Rule: subtract the rightmost digit from 10. Subtract the remaining digits from 9. Add half of the neighbor, plus 5 if the digit is odd. For the leading 0, subtract 1 from half of the neighbor. Example: 346 times 4 equals 1384, working from right to left, 10 are 6, plus half of 0 equals 4. Write 4. 9 are 4, plus half of 6 equals 8. Write 8. 9 are 3, plus half of 4 plus 5 equals 13. Write 3, carry 1. Half of 3 are 1 plus 1 equals 1. Write 1. Equals multiplying by 3 equals. The general idea for multiplying by 3 is that 3 equals minus 2 plus 5. 2x0 qrst, plus 5x0 qrst, 3x0 qrst. Work this as follows. 2x, 10,000, dash 0 qrst, plus 5 times 0 qrst, 20,000, 3x0 qrst. Find the tens complement and double it. Then follow the 5's rule. Remember that doubling the tens complement means you added 10,000 twice to make the math easier. You must subtract that when calculating from the leading 0 and 0 qrst. This means you must subtract 2 from that leading number in your answer before you record it. This is usually expressed as taking 2 from half the neighbor to the right when calculating that last digit. Your digits in your answer should be 0 qrstx3 equals 2x, 9q, plus 5 if q is odd, plus r/2, 2x, 9r, plus 5 if r is odd, plus s/2, 2x, 9s, plus 5 if s is odd, plus 2x, 10t, plus 5 if t is odd. Remember a set of equations for the digits in this example. When a number divided by 2 is written, discard any remainder or fraction. Rule: subtract the rightmost digit from 10. Subtract the remaining digits from 9. Double the result. Add half of the neighbor, plus 5 if the digit is odd. For the leading 0, subtract 2 from half of the neighbor. Example: 492 3 equals 1476, working from right to left, 10 are 2, 2 plus half of 0 equals 16. Write 6, carry 1. 9 are 9, 2 plus half of 2 plus 5 plus 1 equals 7. Write 7. 9 are 4, 2 plus half of 9 equals 14. Write 4, carry 1. Half of 4 are 2 plus 1 equals 1. Write 1. Equals multiplying by 2 equals, rule: to multiply by 2, double each digit. Further note, if you really understand why you are doing the steps, you can create new procedures for yourself, such as for multiplying by 15 by using the 10 rule plus the 5 rule. Add 5 if the number is odd and add 1.5 times the neighbor, discarding any fraction or remainder. General multiplication, The method for general multiplication is a method to achieve multiplications with low space complexity, that is, as few temporary results as possible to be kept in memory. This is achieved by noting that the final digit is completely determined by multiplying the last digit of the multiplicands. This is held as a temporary result. To find the next to last digit, we need everything that influences this digit, the temporary result, the last digit of times the next to last digit of, as well as the next to last digit of times the last digit of. This calculation is performed, and we have a temporary result that is correct in the final two digits. In general, for each position in the final result, we sum for all. People can learn this algorithm and thus multiply four-digit numbers in their head writing down only the final result. They would write it out starting with the rightmost digit and finishing with the leftmost. Trachtenberg defined this algorithm with a kind of pairwise multiplication where two digits are multiplied by one digit, essentially only keeping the middle digit of the result. By performing the above algorithm with this pairwise multiplication, even fewer temporary results need to be held. Example: to find the first digit of the answer, the units digit of. To find the second digit of the answer, start at the second digit of the multiplicand, the units digit of plus the tens digit of plus, the units digit of. The second digit of the answer is and carry to the third digit. To find the fourth digit of the answer, start at the fourth digit of the multiplicand, the units digit of plus the tens digit of plus, the units digit of plus the tens digit of plus, the units digit of plus the tens digit of. Carried from the third digit. The fourth digit of the answer is and carry to the next digit. Trachtenberg called this the two-finger method. The calculations for finding the fourth digit from the example above are illustrated at right. The arrow from the 9 will always point to the digit of the multiplicand directly above the digit of the answer you wish to find, with the other arrows each pointing one digit to the right. Each arrowhead points to a UT pair, or product pair. The vertical arrow points to the product where we will get the units digit, and the sloping arrow points to the product where we will get the tens digits of the product pair. If an arrow points to a space with no digit, there is no calculation for that arrow. As you solve for each digit, you will move each of the arrows over the multiplicand one digit to the left until all of the arrows point to prefixed zeros. Addition, a method of adding columns of numbers, is presented in the book by Trachtenberg. His addition method uses intermediate totals. These are used in an L-shaped algorithm to check for accuracy without repeating the initial procedure. This method allows the precise column in which an error occurs to be identified. For the procedure to be effective, the different operations used in each stages must be kept distinct, otherwise there is a risk of interference. Division. Division in the Trachtenberg system is done much the same as in multiplication but with subtraction instead of addition. Splitting the dividend into smaller partial dividends, then dividing this partial dividend by only the leftmost digit of the divisor will provide the answer one digit at a time. As you solve each digit of the answer, you then subtract product pairs and also NT pairs from the partial dividend to find the next partial dividend. The product pairs are found between the digits of the answer so far and the divisor. If a subtraction results in a negative number, you have to back up one digit and reduce that digit of the answer by 1. With enough practice, this method can be done in your head. Publications: Russian Zyatdan, Sajid Musa. Rapid Mental Computation System as a Tool for Algorithmic Thinking of Elementary School Students' Development. European Researcher 25, 7, 1105-1110, 2012, 1. The Trachtenberg Speed System of Basic Mathematics by Jakow Trachtenberg, A. Cutler, R. McShane, was published by Doubleday and Company, Incorporated. Garden City, New York in 1960. References. External resources: trachtenbergsystem.org,